A loitering munition functions similarly to a small UAV, equipped not only with a compact warhead but also with reconnaissance and observation systems. While operating over a target area, it can remain on standby to perform missions such as reconnaissance, surveillance, and fire adjustment support. Once a target is identified, it can lock on and dive toward it, achieving integrated reconnaissance and strike capability. The value of loitering munitions lies in their ability to significantly enhance the long-range, multidimensional precision strike capabilities of small units. For example, they can be used to repeatedly harass and strike enemy frontline positions and outposts, or to ambush rear area convoys and facilities actions that can disrupt enemy deployment, logistics, troop movements, and operational tempo. As a new category of intelligent ammunition, loitering munitions combine characteristics of drones and missiles while maintaining relatively low cost. With advances in miniaturist control and communication systems, autonomous flight control technology, and tube launch mechanisms, loitering munitions development has expanded rapidly from single-soldier systems to vehicle-mounted swarm launch platforms. At the 2020 China Air Show, several loitering munition products were showcased, among which the CM501XA stood out as a representative model. Within an integrated tactical strike system, it can share fire control, command, and launch platforms with other precision strike weapons, maximizing complementary functions and enhancing operational flexibility and versatility. During a mission, the loitering munition first moves ahead to scout the target area. The information it gathers is transmitted back to the command vehicle, which evaluates the situation and instructs the launch vehicle to fire a precision strike missile. In effect, the loitering munition calls in a precision strike. This approach allows relatively small vehicles to coordinate and generate dense, concentrated firepower. In the future, loitering munitions are expected to evolve into swarm systems operating across land, sea, air, and even space, using fully autonomous and intelligent methods to conduct missions such as reconnaissance, jamming, and precision strikes, becoming a key force on future battlefields. Beyond airborne loitering munitions, new forms of intelligent ammunition that integrate multiple types of equipment have also begun appearing in other operational domains. This device, which resembles a flower receptacle, is actually a smart mine known as the Spider. It has significant explosive power and features 6 directional explosive modules that can be replaced like small cartridges, enabling 360-degree coverage. One of the most groundbreaking aspects of the Spider mine is that it was the world's first networked ammunition system. Each explosive module has a trigger line beneath it, but unlike traditional mines, touching the trigger line does not immediately cause detonation. Instead, it sends an alert and displays the location on a remote control terminal. Operators can then decide whether to detonate, how many modules to activate, and the appropriate timing based on battlefield conditions, allowing a single soldier to manage an entire minefield with high efficiency. With the emergence of new concept systems, such as smart mines and space-based anti-satellite technologies, the expanding family of intelligent munitions now extends from land and air to the sea and outer space. Combined with the growing use of unmanned systems, these developments are accelerating the arrival of a more intelligent and technologically advanced future battlefield. As a new category of equipment built on high-precision technology, smart munitions require not only forward-thinking research and design, but also large-scale manufacturing capabilities to turn concepts into reality. Next, let's take a look inside the birthplace of these advanced systems. Smart munitions rely heavily on intelligent assembly, so How exactly are they produced? The production line beside me is China's first digital assembly and testing line dedicated to intelligent ammunition. The first step in assembling ammunition is preparing the necessary components. Each cart at the entrance of the parts warehouse carries a specialized error-proof pallet equipped with feature recognition and coding systems. Each smart tray contains the components required for a single round of intelligent ammunition. The loading machine records the information of every component, ensuring that each round and each step of the process has its own unique identification. Serial number management enables intelligent error prevention and material verification. Once the materials are prepared, the loader transfers the smart pallet. The pallets are moved to an underground auxiliary line and then conveyed to the main production line. We have now officially entered the assembly stage. Compared with the traditional manual assembly methods of the past, this production line represents a significant advancement in automation, intelligence, and digitalization. Tasks that once required dozens of workers can now be completed by only a few. The team is currently assembling the brain of the smart ammunition, the electronic module. Certain hazardous steps such as live testing procedures are now performed through automated, unmanned inspection systems. This separation of personnel from dangerous operations greatly enhances assembly safety. The staff is now assembling the eyes of the smart ammunition, the optical module. Many steps require the use of air wrenches. Once the torque is preset, any operator can achieve consistent torque output, improving overall product quality. Automated assembly equipment replaces manual labor, and the combination of robotic manipulators with high-precision testing systems allows the entire assembly process to be completed efficiently. Since this production line was established, it has significantly improved product quality while reducing the physical workload of personnel. However, some processes in the assembly workshop still cannot be fully automated, such as parachute packing. Here, staff members are folding parachutes for the smart ammunition. The parachute's primary function is to slow and stabilize the munition during descent, ensuring a steady search posture. It is a key component that directly affects accuracy. During parachute packing, workers must repeatedly check for tangles between the cords and canopy, verify that the cord lengths meet technical requirements, and ensure that the locking rope is not intertwined with other parachutes. This prevents entanglement during deployment. Let me give it a try. Show me how to thread it. The process begins by threading the cord through the designated loops. While threading, you can straighten and organize the lines at the same time. This one has crossed over the line behind it. I'll need to fix that later. What seems like a simple step is actually quite challenging to perform correctly. Although automation and intelligent systems now handle most tasks, some steps, such as parachute packing, still require skilled human hands. The staff members work with great focus, demonstrating patience and a strong sense of responsibility. As the final assembly unit for this type of intelligent ammunition, Liaoxin Group is also China's largest and most comprehensive research and production base in this field. It has achieved significant progress not only in key technologies such as efficient damage mechanisms, precision machining, and new high-energy charges, but also in engineering applications including automated assembly and testing. The successful development of this ammunition fills a domestic gap and marks an important milestone in China's research on anti-armor cluster targets. Smart ammunition must not only be intelligent, but also sufficiently capable and effective. The next step here is a static detonation test of the smart ammunition. A static detonation test is conducted on the ground, allowing researchers to evaluate the overall damage performance of the ammunition and accurately assess its battlefield effectiveness. Because this ammunition is designed to counter heavily armored targets, homogeneous armor plates thicker than a clenched fist are placed in the test area. The steel wall behind the armor plate is marked with numerous impact points from previous fragment tests. Staff members are making final preparations for the static detonation test, and personnel in anti-static suits are transporting the test round into the firing chamber. Once inside, you can see that the steel wall is covered with fragment marks. These various traces were created during earlier tests. For safety reasons, we cannot remain near the firing chamber and must take shelter inside the bunker. Three, two, one, begin! We have just completed several rounds of smart ammunition detonation tests. As we enter the test area now, there is still a faint smell in the air. Now, let's review the results with the staff. Looking closely, we can see that the armor plate has been penetrated. It has been fully perforated. Director Wang, could you explain the outcome of this test? The experiment was very successful. He says, the results meet all required performance indicators. This means the product has completed development, is ready for mass production, and will contribute to national defense while supporting the development of future systems. Li Aoshin Group will continue working to develop effective, reliable, and durable equipment, contributing further to national defense capabilities. Modern information-based weapons and equipment represented by intelligent ammunition are profoundly reshaping battlefield environments and combat methods. With ongoing advances in science and manufacturing technology, it is likely that even more diverse and innovative smart munitions will emerge in the future. You're welcome to scan the code to follow the CCTV military and sort accounts on the CCTV video platform, or interact with us through CCTV military's Weibo and WeChat channels. Alright, this is Sword. See you next time.